video, we're going to review how to round. We started out when we were first learning to rounding to the nearest 10 using 2 digits, and we actually used a number line as a tool to help us see how rounding works. We decided that 47 would come between 40 and 50 on a number line, and then we would go through and number all of the numbers in between those. So 41, 42, 43, 44, 45, 46, 47, 48, 49. Eventually students didn't have to number all of those. They could kind of just count in their head and mark where 47 was. And then I would ask the students, is 47 closer to this end of the number line or this end of the number line? And they would say it's closer to 50. Therefore 47 rounded to the nearest 10 rounds to 50. We can do this with 3-digit numbers also. If I have 337 rounded to the nearest 10, the 337 would come between 330 and 340 on the number line. 2, 3, 4, 5, 6, 7. And we could mark where 337 was. You notice I didn't put all of the numbers on the number line, but you heard me count forward and find exactly where it was. And the students would say, oh, 337 rounds to 340 because it is closer to 340 on a number line. We can do this with hundreds. The number lines with the hundreds are a little tricky. Obviously, we're going to find the 200s that 789 is between. Numbering this number line, the numbers in between, a lot of students want to go 701, 702, 703, when actually they need to be numbering it by the 10, just because this is a little more efficient and nobody wants to write 100 numbers between 700 and 800. So we'll jot those down in between, and then 789 would be about right here, and it would round up to 780. If we change this number to, let's say, 721, it would go about right here, and this number would actually round down to 700 because it's closer to 700 than it is to 800. Eventually students would stop using the number line and rely more on just knowing, visualizing that in their head, and we had a rhyme that we used to kind of help us. If our number was 81, the poem is kind of in the voice of whatever the underlined digit is. So in this case, this is the 8 talking. On the left, I stay the same. To the right, 0 is my game. So everything on the right turns to a 0. Do I go up? I being the number 8. I must decide, is my neighbor 5 through 9? In this case, it is not 5 through 9. So this underlined digit stays the same. So 81 rounds to 80. You can do it any way that you would like, or with any place value that you would like to round to. You can do 3-digit numbers. On the left, I stay the same, so this 3 would stay the same. To the right, 0 is my game. Do I go up? I must decide, is my neighbor 5 through 9? In this case, my neighbor is 5 through 9, so my number 6 will go up to a 7, and 367 rounds to 370. Now, sometimes we run into an instance when the left does not actually stay the same. For instance, let's do 491 rounded to the nearest 100. 1,491 rounded to the nearest 100. On the left, I stay the same. To the right, 0 is my game, so all those turn into zeros. Do I go up? I must decide, is my neighbor 5 through 9? Yes, it does go up. But what would happen if this number was a 9? If I change that number to a 9, then going up 1 wouldn't work. 9 would actually have to go up to 10, and we can't have 10 in any place. So in that case, our little poem doesn't work perfectly, but most students understand that the 10 cannot go in one place, so you have to add the extra over here in the thousands place. So 1,991 would actually round to 2,000.